Today we have with us our presenters Brad James, Manager, Wolfram Alpha Math Content, and Jeremy Stratton-Smith, Lead Developer, Wolfram Alpha Math Content, and they will talk to us about getting accurate and curated knowledge, data, and computations from your ChatGPT session.
From the Wolfram website, we have a page dedicated to accessing the Wolfram plugin for ChatGPT. There are detailed instructions here under the installation instructions, including screenshots of how to access this plugin. And I am going to dive into looking at what does the Wolfram plugin actually enable us to do from within ChatGPT. Obviously, ChatGPT is an amazing piece of technology that has really great skills. One of the things that we are augmenting ChatGPT with Wolfram technology is the vast resources of curated data and specifically computational and symbolic, algorithms and power behind Wolfram. So I'm going to be showing examples live. There should be a notebook also linked in the chat that includes screenshots of the particular examples. Because of the non-deterministic nature of large language models, what you get from one input may be different the next time that you input the same input. So one of the first things that we're able to enable here is really just being able to access real live up-to-date data. So the cutoff for when ChatGPT was last trained, the model behind it was last trained, was sometime in 2021. So it does not have access, if you ask it without the Wolfram plugin, it doesn't have access to information such as what film won Best Picture at the Oscars this year. But using Wolfram Alpha, and as Alan showed yesterday, I'm going to show this while it's still writing out things, we're able to ask something like Best Picture winners. This is what's being sent to the Wolfram API. And not only are we returning just the specific answer, but we're also returning a whole bunch of other related information, which then ChatGPT is able to synthesize into this nice paragraph explaining not only just that Everything Everywhere All at Once won the Oscar for Best Picture, but also some related details, including release date, genre, money, how much it grossed at the box office, and so on. And sometimes it will even include a link to take you over to Wolfram Alpha if there's more information to be shared. So that's sort of a starting place of what kinds of information are we able to share. And for those of you who are familiar with Wolfram Alpha, there's many areas and domains of data that we have access to. But one of the sort of classic things is being able to do comparisons of different kinds of data. And so ask this for what is the population of France divided by the area of Illinois? And here as I was typing live, I made a little typo, but ChatGPT is smart enough to be able to understand that. And so you can see here, again, we're returning a number of results, including that this is based on a 2021 estimate for, I believe, the population of France. And so ChatGPT accurately represents that and gives us not only just the 1,110 people per square mile, but also a few different unit conversions there. But in addition to being able to do lookups of the data nature, as we were just seeing, through the Wolfram plugin, we're also able to do more complicated computations that really require not just a data lookup, but something that where ChatGPT is going to be writing some code. So I'm going to give another attempt here and say, can you show me the first 20 Fibonacci numbers? Then show me the number formed by concatenating them together, and finally factor that number. So there's a number of related computations happening here. And right off the bat, it starts calling the Wolfram plugin. And I'm going to show that this is actually live in front of us, building some Wolfram language code that is nicely commented to show us what exactly is going on. And as soon as it gets returned, it's going to start doing what I've asked it to do. So the first 20 Fibonacci numbers, writing them all out. It got the result of concatenating them all together. And this is the kind of thing that a large language model would struggle with, where there's actually some, fair, not necessarily heavy duty, but there's some involved math happening behind the scenes to take this very, very large number and factor it. And this is something that, unless somewhere out on the web somebody's already done this problem a bunch of times, a large language model is going to struggle to access. So with that, these are just a few examples of being able to access data as well as access accurate computation through the Wolfram plugin. And with that, I'm going to be handing things over to my co-presenter for today, Brad Janes.
Hi, thanks so much, Jeremy. I'm starting with this fun prompt, letting it know I'm giving a presentation, so try to keep its responses short. And also, instead of having to switch between new chats, telling it like, hey, use Wolfram or don't use Wolfram based on my input here. So we can kind of see some things and how it is more or less successful with certain queries based on using our plugin. Well, okay. Well, so much for that idea, I guess. We can try some of my examples then. And let me just turn off the plugin so that we can see what we're going to get here. This is a simple kind of, math word problem. It's kind of a unique kind of problem in that it's easy to see and figure out and understand, but there's a little bit of complicated things that are going on in the translation from the words to the equations. And it typically has been doing okay at getting that right. And again, this is without using our plugin at all. I know the answer, and saying something is 1.4, I believe it is not going to be getting the answer correct here. Well, it did get it finally. Okay, wonderful. It kind of went through and saw that it made a incorrect assumption. Well, if we do the same problem but use the Wolfram plugin, hopefully the reasoning will be quick and it will return the answer in a relatively quick way. Like Jeremy said about the non-deterministic nature of language models like ChatGPT, I've tried this same problem numerous times and it is giving me all sorts of answers for the result. Okay, so here it set up the two equations and hopefully it will call Wolfram here, and there we go. The answer of the equations is 7 and 5, so there we go. I think I will continue starting new chats here. Another kind of mathy example. We're from the math team, so it's kind of how we spend most of our focus on. Here's one that kind of gets at similar to Jeremy's last example, where we are doing a bit of a word problem thing, but it's a lot of large numbers, which ChatGPT does have tends to have more issues computing with large numbers. Boom, it's like a 29-digit number. Usually, when asking it without the plugin, it might give us the kind of simplified form of 2 times 3 to the 30th squared. But yeah, this one just evaluates the number and we get the very large integer, which is fun. All right, well, how about another example that kind of brings all of this stuff together, where we have large computations, but also some data lookups and things that Wolfram and Wolfram Language and Wolfram Alpha both really excel at. So here is a relativistic problem, kind of from your astrophysics class, um, talking about traveling at a percentage of the speed of light and comparing that to some real world data, such as the distance to Jupiter, the speed of a particular ship. And it's making several Wolfram calls. This is not uncommon to see. All right, so it's giving us the distance to various astronomical objects and kind of restating the problem here. It looks like it did not take any relativity into account with that part of the problem. And then, yeah, so it works out the problem, and then it tries to do another call to Wolfram to make sure that the answers that it comes up with are correct. And yeah, I mean, this is something that can come up. Like while we are, the Wolfram plugin is available, it's only going to be able to answer questions that ChatGPT decides to ask it. So if it doesn't take into account the relativistic nature of going that fast, and the time that would be diluted, it might not necessarily ask us that part of the question. It might just assume non-relativistic computations. Anyways, this is a bit of an advanced example. I'm curious why it's taking so long here. Oh, it is continues to be writing the code and commenting on things, and well, we can let it finish. Oh, and there's problem formatting the code. Yeah, and sometimes it makes an error in the coding itself. So this is typically not a Wolfram plugin error. It's typically a ChatGPT issue where it is, forgot to close a bracket or something. Well, we can wait again, or we can try one more example here, maybe something a bit simpler. Let's see. We can solve a system of equations with the Wolfram Alpha plugin. All right. Restating the problem, and it formats it nicely. And there we go. So again, while ChatGPT has been growing and getting a lot better with things like data lookups and computation, it's certainly something that uh, when it uses the Wolfram plugin, you can be more sure that the kind of numbers that it comes up with are correct. And if you're still curious, you can kind of take a look and see what the actual request was and what the Wolfram response was. So you can see that we computed the result just like that, and it interpreted that into its own result. Let's see, are there any interesting questions that have come into the chat? Maybe some other live examples that we could try, or
Somebody
like
asked about making 3D plots.
Oh yeah. Oh yeah. Okay. So plot a 3D image of, and I can. A typical example that we like to give is sine of x times y. That's kind of a fun one that we do for a lot of our internal demos and promos, but maybe we can do a more exciting one. right? I know there are other LLM type models that are very image based. And GPT-4, I believe, is supposed to be able to do things with images. But here, using our plugin, ChatGPT can return an image just like that. Another thing that I think we have data for in Wolfram Alpha that we can return through this. It's very funny to me that it writes out the link like that, as if it doesn't know the full link. Anyways, I guess that's 2 femur bones, but that's fine. Cool.
Another example that somebody asked about what would happen if we give it a system of equations that has an infinite number of solutions instead of just a singular.
Ooh. Yeah,
I have an example for you.
Sure, perfect.
Yeah. If you want to ask it to solve, this is pretty basic, but x plus y plus 3z equals 2, and x plus y plus 2z equals 1. And
Okay. Oh, I made a typo. This will not be that case, but yeah, we can try again. It's kind of an underdetermined system, right? We have 3 variables, but only 2 equations. But yeah, it looks like we solve it very nicely. All right, so let's do the one where this is actually z. Okay, so a similar situation where we have we kind of grant a family of solutions. An interactive image, I think not at this time. Right now, ChatGPT is only allowing for embedding of image files that are static. Oh, when you ask ChatGPT to plot a function of 2 variables, do you know how it chooses the domain of the plot? So ChatGPT is typically not choosing the domain of the plot. That's typically a Wolfram Alpha thing. You could, of course, tell it a particular plot range. So I can do x plus y from x equals 2 to 4 or 5 and y. Okay, so probably not a very interesting plot, but this should be interpreted and should be picked up by the plugin and hopefully give us a nice image.
As this is running, there's another question about how does this differ from Wolfram Alpha itself with some of these inputs? And I think that's a good question. And one of the fun things about working, across in relation with another company is there's many pieces that are moving. So sometimes sometimes they'll be updating something on their side, and we'll run into little blips like what we're seeing today. But in terms of the longer term, how does this differ from Wolfram Alpha itself? You can have a long conversation with it. And there have been times where it doesn't style the plot the way that I want. So I say, can you make that prettier? Or can you make that blue? And so on. So the conversational nature of it, it's making use of Wolfram Alpha in addition to the conversational aspects.
Yeah. Someone else asked about a high-res image of a fractal, such as Mandelbrot set. We can obviously get an image of various fractals and fractal-like objects using the Wolfram plugin. As far as getting like a high res image, we're currently limited in the kind of file size um, of the image that we can provide to them. Um, so there's kind of some constraints there. It's really interesting when you can go back and forth and have, uh, you know, getting multiple. Well, I guess my example of the space one, where did that one go? Where it made multiple calls to the plugin and then used results from each of those together in writing its kind of paragraph response. So that's something else that's a little bit different, where even within a single query, it can get multiple pieces of information and then make different like computation calls, um, as it's kind of like having a conversation between itself and, from the prompt that you made, uses the various calls to the plugins. Um, yeah, things like that.